Welcome to Section 6, Automation, Pipeline Orchestration, and CI/CD. In this video, we will get an overview of the pipeline. Automation, pipeline orchestration, and CI/CD are separate items of concern, but when talking about a pipeline, they are inclusive. What is a pipeline? The pipeline is a term that refers to the building, testing, and deployment of application code in a sequential and automated fashion. The pipeline is what most think of when hearing the term DevOps, and for good reason. It's the primary focus of DevOps. As a DevOps engineer, our job is to prep, test, configure, and deploy the development team's applications. This is done with consistency, reliability, and traceability in mind. Let's run through an illustrated representation of a pipeline to get a high-level overview, then we'll drill deeper. Imagine that a team of developers are working on an application. They are all working on separate features or tasks in an effort to contribute to the application. As each developer finishes a task, they commit their changes to source control. When doing so, it kicks off a chain of events that will build, test, and deploy the application. If the code fails at any point, then it will cease to progress through the pipeline. If the code passes every phase, then it will be deployed into an initial environment like the development environment. From there, it can continue through multiple environments, depending on whether the code should progress. This is a good time to talk about Git and workflow. Git is a source control tool that was developed by Linus Torvalds while working on the Linux kernel. There are other types of source control, and each can work with the pipeline, but in my opinion, Git is the most suited. Git has the notion of a distributed environment. This means that there isn't a controlling repository that manages working copies of files to be checked out. Every person that has access to the repository has a fully working version of that repository, although they could be in various states, and in fact are likely to be so. A Git repository uses branches. Every repository starts with a master branch. Developers can develop directly on the master branch, but it isn't the best way. The main branch or another designated branch should be the base branch in which all other branches are based from. So when a developer wants to work on a new feature, then he or she can create a branch from the base branch as a starting point. This new branch has all of the code from the base branch up to the point that the new branch was created. This creates an independent line of development. It also fosters parallel development, since each developer can work on their feature without affecting the other developers. The new branch changes, either when the feature is done or periodically, can be applied to the base branch by doing a merge. Let's look at a scenario. Imagine there is a team of 3 developers named Jill, Tom, and Fred working on a financial tracker project that will use Git source control. Tom creates a new project repository on his computer and shares the URL with Jill and Fred. Jill and Fred each run a Git command to create the same repository on their computers. Each member of the team has a version of the code repository on their machine. This makes Fred the host, but there is nothing that says he has to be the only one. Because each person has a fully functional Git repository, both Jill and Fred could easily add each other as additional hosts, but this isn't commonly done. Jill is tasked with adding a new balance endpoint to the application API. So she creates a new branch from master named balanced endpoint and proceeds to work on the feature. Fred is working on a new navbar, so he creates a branch named navbar from master. Tom is working on a feature named forecast, and he does the same. Now each person has a version of the repository on their computers, but they all differ because of the newly created branches. Once Jill finishes, she can push her changes to the remote repository on Tom's machine. Fred can pull down Jill's changes to update his repository so he can review Jill's work. If everything looks good, he can merge Jill's branch to the master branch and push the changes back to Tom's computer. Even though we use Tom computers as the host, or as it is called in Git, the remote, this isn't typically done. Services such as GitHub, Bitbucket, and Azure DevOps Git are typically used as the host. They provide some additional functionality on top of Git, such as managing authentication, pull requests, hooks, etc. Now that you understand how Git works, let's talk about workflow and some rules that will form the basis for a sound workflow. There are some popular workflows out there, and one of the most popular is called Git Flow. Git Flow was developed for use with agile development, but could be used with other methodologies. Git Flow works by establishing different types of branches and some rules for working with those branches. The master branch is a persistent and protected branch that is used to store code that has been released. The develop branch is branched from master and is a persistent and protected branch for storing developed features. When I say protected, I mean that these branches can't be deleted or committed to directly. Changes must be merged from another branch. New development is done by branching from the develop branch to create a feature branch. There can be multiple feature branches. Feature branches are not persistent and are removed once the feature is done and the branch merged back into the develop branch. This makes the develop branch the most up-to-date branch for the project. It is vitally important that the develop branch code be in a working state since it provides the basis for feature development. The first line of defense to ensure bugs don't creep in is with peer review in the form of a pull request. A pull request is a way to notify reviewers that code is ready for review and allow the reviewers to comment, approve, or deny the request. Release branches are branched from develop at the point where the last merged feature to include was committed. The code for the release can then be deployed into a test environment. Any issues found will be handled on the release branch and merged back into develop to keep it current. Once the release is ready, the release branch is merged into develop and into master. The release branch can then be deleted, although if necessary to maintain legacy versions of code, then it can persist. The master branch tracks released code this way. So any hotfixes that need to be made are branched from master to a hotfix branch, then merged back into master and into develop. As I said earlier, this works well with agile development, but it isn't ideal for DevOps. There are some huge issues with this. At the end of a sprint, each developer is rushing to get their code merged into development so that a release branch can be made. Since Git will not allow conflicts, which is changing the same line of code in two different branches, this makes it difficult. Remember, DevOps lives on short iterative cycles, so we don't want to wait to merge new code. Think of code in the DevOps way as a subscription that is delivered rather than a bi-weekly purchase. Enter Flow, although simple, my own creation for adaptivity and integration into the DevOps philosophy. Flow has two branch types, protected and work. The master branch serves as a development and release branches if comparing to Git Flow. The holy grail of DevOps workflow is to think of every new work branch merged to master as a release. Each feature or bug fix is branched from master as a work branch. Every commit, whether work or master, gets sent through the pipeline to build and test, but only the master branch commits can pass through to the development environment and beyond. Now, this workflow won't work for every application, team, or organization, so you as the DevOps engineer will likely need to create a hybrid workflow and implement it. For instance, what if a team has external dependencies to coordinate, or they need to maintain legacy release versions? Flow is highly adaptable and is meant to be as dynamic as DevOps and the pipeline needs.